Hello everyone and welcome to our new technology release. We're excited to finally reveal this amazing project we've been working on in parallel to our FFF products. After 3 years of intense work, it's a privilege to be in this position, and it's time to share it with all the industry. After all of today's information and insights, we are sure that you will want to get involved straight away. That's why we've prepared our technology adoption program, where, whether you are an individual or a company, you can be part of the journey that begins today. I'll explain how this open program works a little bit later. But in the meantime, feel free to comment on the chat, where our team is ready to answer any questions. VCN 3D has lived the expansion of 3D printing from the inside. We started from the basics, like many other companies that have flourished during the last 10 years, with our accessible FFF printers for those who weren't aware of the capabilities of the technology. FFF is for us, and will continue to be, the easy way into 3D printing. It is from the experience of introducing 3D printing to so many people and companies that we value and understand the importance of accessibility to our users. Inexpensive, simple, and easy-to-use printers were, and still are, part of the expansion of the market. During the last few years, new players, some are small and others not so small, have arrived on the scene to spark drastic technological evolutions. Nowadays, 3D printing is a technology that is more applicable than ever, with presence in many design and fabrication workflows across many different applications. This is a clear indication of the potential of this fabrication method and shows a bright future ahead. It is also true that this technological evolution has focused on improving the capacities in terms of performance and productivity, but it has set aside the accessibility required for a bigger, wide-scale adoption. Every single actor in the industry is claiming that 3D printing offers flexibility for any client's workflow. But in reality, this degree of flexibility is actually unattainable because of the high entry cost. Huge investments in money, people, and space have to be made to experience the maximum potential of this tool. But this is a stopper for many users and their desired applications. It is for this reason that we want to put forward a solution that brings accessibility into the mix, while maintaining the same level of performance and productivity. We want to put a technology in the hands of our users that brings them manufacturing autonomy and the ability to create parts at a competitive level without worrying about the initial investment. We believe that the technology we are presenting today is the best way to do so. If 3D printing is to be the future of manufacturing, and what leads us towards local production, customization, control of supply chains, and sustainability, all the players in the industry should be pushing in this direction. At VCN 3D, we think that today is the first day in achieving this goal. We want to show 3D printing in a new light, so that it becomes the pivotal point of manufacturing. I hope you will enjoy this presentation as much as we will. Now, please welcome to the stage our CTO, Eric Pallares, who will explain what it's all about.
Hi there, I'm Eric, CTO here at VCN 3D. As we've just heard from Xavi, to truly unlock manufacturing autonomy, it is critical to provide a solution that simultaneously encompasses accessibility, part performance, and productivity. At VCN 3D, we've been working hard for the last 3 years to develop such a solution and make our vision a reality. I am excited to introduce our brand new 3D printing technology to the world, VLM. VLM, or Viscous Lithography Manufacturing, is a patented 3D printing process that utilizes high viscosity resins to produce high-performance parts extremely quickly and in affordable and scalable way. Before going deeper into the technical details, let's review the rationale behind the VLM naming, which gives away many clues about how it works. Let's start with the M, manufacturing. VCN 3D aims to provide an additive manufacturing solution to achieve mass production. 3D printing has evolved from a rapid prototyping tool into a clear trend in manufacturing. However, an affordable solution to reach all levels of manufacturing, including small and medium-sized businesses, is needed. Initial investments are a big stopper for companies not capable of shelling out €500,000 upfront to start manufacturing, like with, say, a powder-based technology. That brings us to the central letter of the VLM technology, L for lithography. VLM is a resin-based technology that, by using light source consisting of UV light and an LCD screen, becomes an affordable and productive solution, delivering a constant time per layer, regardless of whether we are printing 1 or 100 parts at the same time. But perhaps you think that printing resin is not new at all, and most of the existing resin technologies produce parts too brittle to be used in a real, demanding environment. At VCN3D, we want to change that conception and print real parts with resins. So how is that possible? Let's return to the first letter of VLM, V for viscous. The viscosity of a fluid, simply put, strongly depends on the molecular composition of the formulation. VLM technology is capable of handling resins up to 50 times more viscous than the industry standards. This is VLM's secret sauce. Higher viscosity opens the door to better part performance. And good performing parts mean they can be used beyond prototyping as a final part in a broader range of real-world applications. So yes, VLM is VCN3D's proposal to unlock manufacturing autonomy, the best way to affordably produce thousands of high-performance parts. Let's learn a bit more about this game-changing new technology.
Introducing VLM, Viscous Lithography Manufacturing, a breakthrough 3D printing technology that unlocks manufacturing autonomy. VLM is a patented lithography-based 3D printing process that utilizes high-viscosity resins to produce high-performance parts extremely quickly and in an affordable and scalable way. High-viscosity resins can be managed using a 3D printing lamination process, on which VLM is based, avoiding the drawbacks associated with conventional resin 3D printers that use tanks or vats. To do so, the resin is first picked up by a roller and accurately laminated to the underside of a transparent film, which is then transferred to the printing area. The build plate rises to come into contact with the recently laminated resin at the desired layer thickness. The UV light engine cures the resin solely in the specified area, creating the new layer of the object to be printed. The build plate then retreats, causing the recently cured layer to peel away from the film, while the unused resin is recovered and recirculated up to the reservoir. This process is then repeated until the print job is complete. VLM's mechanical system allows the resin to be laminated from both sides of the film, making it possible to implement strategies to speed up printing times, or even to combine different resins to get multi-material parts and easy-to-remove support structures. This technology aims to provide manufacturing autonomy to the industry, which consists of the three main pillars of providing superb part performance, a high production capacity, and accessible and frictionless operation. VLM is capable of working with resins 50 times more viscous than standard ones. The higher the viscosity, the wider the range of ingredients available for formulating, such as fillers or high molecular weight oligomers. This results in resins with improved mechanical and thermal properties, yielding an endless range of applications. Within the world of 3D printing, there are three main printing layer fabrication strategies: rastering, jetting, and image flashing. VLM takes advantage of the latter, using a high-power light source to cure the whole printing area in a very short time. This technology is easy to scale up simply by using a bigger LCD screen, since it is not limited by the vat dimension. This combination of a large surface area and quick layer time makes VLM the most productive additive manufacturing solution on the market. VLM uses monocomponent resins formulations printed at room temperature, avoiding pot life limitations and speeding up setup times. Thanks to its proprietary lamination system, the absence of a resin vat means that no initial investment of resin is required. And given that the system filters and recirculates resin, VLM achieves zero waste. Every single drop of resin in the system will eventually become a printed part. VLM technology has been born to unlock manufacturing autonomy. It elevates 3D printing from being solely a tool to instead becoming the pivotal point of manufacturing.
Okay, so let's sum up some of the key ideas seen in the video. VLM is a resin-based technology that uses UV light and an LCD screen to photopolymerize high-viscosity resins in a 4-step lamination process. The resins, up to 50 times more viscous than industry standards, are monocomponent formulations and printed at room temperature, opening the door to a better part performance for a broader range of real-world applications. And given that the system filters and recirculates resin and pot life is not a limiting factor, we achieve zero waste. Every single drop of resin in the system will eventually become a printed part. And last but not least, thanks to the proprietary lamination system, VLM is also capable of effectively printing in dual material. Arriving at this point, I feel that it is mandatory to emphasize the important role materials play in the new VLM technology. In order to fulfill our vision and achieve the very best formulations possible, at BCN3D, we are honored to count on the expertise, help, and counsel of a major player in the chemical industry, Arkema. I'm glad to invite 3D Market Manager Helene Gret to join the stage to explain exactly why VLM technology has the potential to disrupt the 3D printing industry.
Thank you very much, Eric. I'm very happy to share the stage today and to take part in the VLM adventure with you. Hello, everyone. I'm Hélène, and I lead the market coordination for liquid resin in 3D printing for Arkema in Europe. Today, I will explain and share our commitments to designing innovative material to support BCN3D's new technology. But first, let me quickly introduce Arkema and its contribution to 3D printing. Arkema is a leader in specialty materials and design solutions to address the ever-growing demand for innovative and sustainable materials, driven by the challenges of new energies, new technologies, the depletion of resource, mobility, and increasing urbanization. Sustained by a collective energy of its 20,000 employees, Arkema operates in 55 countries and reports sales of 8 billion euros in 2020, well balanced across regions. Innovation is our engine and lies at the heart of Arkema's strategy. 1,600 researchers work in our 15 R&D centers across the 3 major continents. To design the material of the future, Arkema relies not only on strong R&D, but also on a collaborative research strategy via partnerships. Our researchers' work revolves around 5 R&D platforms where 3D printing technology holds a strong position. In this field, Arkema offers an industry-leading portfolio of material and is committed to unlocking new opportunities by bringing comprehensive solutions and expertise to our clients. Recognized as a key player in the 3D printing industry, Arkema offers the most extensive range of material dedicated to additive manufacturing, spanning all major printing processes, UV curing, powder bed fusion, and material extrusion. Let's dive into the material of interest for our discussion today, the liquid resins. Arkema is a pioneer in designing high-performance photocurable resins. Decades of supporting the 3D printing industry allow us to be uniquely positioned to build innovative resin solutions. Global teams of dedicated scientists and distributed centers of excellence have already enabled the success of our partners with next-dimension photocurable resins in many markets. From our toolbox, we can synthesize custom structures from a portfolio of oligomers, monomers, photoinitiators, and more, we can deliver advanced thermosetting engineered resins and engage in collaborative development to bring custom formulations applicable to specific needs. Arkema's strength is to develop specific offering suited to the challenges of main sector of activities. The key to success is to bring sets of expertise together. The high-performance materials for 3D printing are evolving alongside the advancement of additive manufacturing technology. What is happening today is the perfect example of what can be achieved when innovative companies like BCN3D and Arkema work together. We strongly believe in BCN3D unique VLM technology, which opens the path to thermosetting resins to further evolve mass manufacturing and the production of functional parts. One of the key challenges related to thermoset's properties is the consequence of the narrow viscosity range that can be processed by standard printing technology, limiting our capacity to formulate 3D printing products for demanding applications. But since VLM technology was specially designed to effectively handle high viscosity resins, it overcomes this major limitation and therefore open many new opportunities to develop extraordinary thermosets and bring the mechanical properties to a completely new level. Since the early stages, we have worked alongside BCN3D by adapting our existing products to their needs and supporting them closely. Together, we have built a roadmap to develop best-in-class materials, respond effectively to a broad list of specifications, while being strongly driven by use cases and real-life projects. The proven capability of VLM to manage high viscosity resins brings a longer-term horizon to our collaboration. We envision a great prospect to develop new building blocks and enable game-changing formulation to meet applications requirements unreachable with existing photocure technologies. For Arkema, this is a great opportunity to contribute to the growth of 3D printing technologies, and we value the chance we have to unlock manufacturing autonomy with this development agreement. The team is eager to continue our collaboration and produce actual projects with the very promising VLM technology. With this, I thank you again, Eric, and the floor is back to you.
We are so grateful to Hélène for being here, as well as all the team at Arkema for their supportive words, help, and passion towards unlocking manufacturing autonomy. So far, you've gotten a first glimpse at what VLM is, but now it's time to dive deep into the technical details to explain how VLM technology effectively solves the three main pillars that serve to unlock manufacturing autonomy. To begin, BCN3D's head of materials, Dr. Dario Destro, will cover how VLM can print game-changing high-performance parts, followed by a use case developed together with Prodrive, a member of the VLM Technology Adoption Program. This will be discussed in detail later, but such a program is a unique endeavor to let companies be the first to explore the full potential and benefits of VLM. Then we'll move to product manager Diego Prado, who will reveal what makes VLM such a highly productive and scalable technology. Here, you will be informed by manufacturing world leaders, Saint Gobain themselves, another participant in the VLM Technology Adoption Program, about their efficiency transformation and increase in productivity. Lastly, I will share some insights about accessibility, not only in financial terms, but also regarding its operation and sustainability. So let's not keep Dario waiting any longer.
Thanks, Eric. As head of materials, my focus lies in the core of our resin technology and its integration into the VLM platform. Due to the process limitations of traditional resin-based 3D printed technologies like SLA or DLP, the formulations are constrained to a very narrow range of viscosities. In order to extend that range and be able to obtain better part properties, some printers heat up the entire resin vat up to 60 degrees Celsius. However, there are a few drawbacks to this approach. First of all, the process requires a conditioning time before starting. Secondly, the volatile components of the resins are released into the air, potentially reducing the safety of the process. And finally, the most critical inconvenience, the physical properties of the resin can be altered as the polymerization can be partially triggered by heat, leading to non-homogeneous mechanical properties along the Z-axis. However, thanks to its proprietary lamination process, VLM is capable of dealing with a much broader viscosity range, always at room temperature. Extremely viscous formulations, up to 50 times more viscous than industry standards, are perfectly laminated into a thin layer of materials on the top of the film in a mild and safe fashion, avoiding the aforementioned drawbacks from heating strategies. Why is that? How can high viscosity lead to game-changing materials? Without a strict low viscosity constraint, the chemist obtains freedom to formulate, as a whole new set of ingredients and modifiers can be included in the resin. For example, imagine you're asked to bake a cake with 3 ingredients: eggs, flour, and sugar. It's possible, but a bit of a challenge. Given the same task, but with the chance to buy anything you desire at the supermarket, would rid you of limitations and give you much tastier outcome, wouldn't it? Following this analogy, by raising the viscosity upper limit, the chemist has access to a much broader list of building blocks, so more solid and viscous ingredients can be added in order to achieve the desired effect on thermal and mechanical properties, thus unlocking new applications. Okay, so now that the benefits of printing with high viscosity at room temperature are clear, let's discuss 2 formulation strategies that can be used in order to unlock new applications. First idea, add impact modifiers for more demanding mechanical applications. This strategy is commonly used in the industry to improve the properties of advanced materials, adhesives and coatings, since it causes a great improvement of the impact resistance in brittle materials. But impact modifiers are solid ingredients and even in very small quantities greatly increase the viscosity of an acrylic resin, becoming unusable in traditional resin-based technologies. But viscosity is not a problem for VLM. A large amount of impact modifiers can be added to reach an optimal filler loading, thus taking advantage of mechanisms such as crack deflection. As a result, VLM resins can obtain triple the amount of impact resistance for rigid materials compared to equivalent standard formulations. A second strategy to improve performance is using high molecular weight ingredients for better elastomeric applications. Low viscosity formulations are mostly composed of monomers that, when polymerized, create a high number of branched short chains, resulting in a more brittle polymer backbone and poor elastomeric behavior. In contrast, without viscosity limitations, VLM resins can include a high fraction of oligomers. When the light is shone, a loosely cross-linked polymer network is obtained. This internal structure is capable of withstanding mechanical stresses in a flexible manner, behaving like industrial-grade molded elastomers, such as vulcanized rubbers, silicones, and polyurethanes. As a result, mechanical properties such as strength, toughness, and tear resistance are significantly improved. For this reason, VLM resins aim to obtain 200% increment in tear strength compared to current industrial standard formulations. We could spend hours discussing the benefits of high viscosity resins. We named a few, but there's also improved aging resistance and stability and lower volatility, which often translates into a safer product, more likely to be certified as biocompatible. But to sum up, the main takeaway here is that you'll never reach industrial equivalent products with low viscosity resins. Processing high viscosity resin at room temperature is a groundbreaking way of achieving the countless benefits that come with manufacturing autonomy. Now it's time to give you some tangible context to my explanation with a case in the real world. Our second guest comes from the world-renowned motorsport and advanced technology company Prodrive, one of the first in the world to put our technology to the test through the VLM technology adoption program. They've been assembling end-use parts mounted directly on cross-country cars. Here to tell us all about it is Prodrive design engineer Callum Harper.
Thanks for the intro, Dario. Prodrive is well known for its competition success in both off-road and circuit racing disciplines. We're the team behind the multiple world championships for Subaru and Aston Martin racing, amongst many other victories throughout our near 40-year history. Based in Banbury, in the heart of the UK's motorsport valley, Prodrive is engaged in three main streams of business. Aside from motorsport, Prodrive's advanced technology group uses this same ethic to provide fast-paced and innovative solutions for customers in a wide range of industries, including automotive, aerospace, defence, and more. Our third pillar is our own composites facility, one of the largest of its type in the UK. Here we make most of the composites for our motorsport programs, as well as high-class components for prestige automotive OEMs and the aerospace industry. Prodrive has a great history in endurance events such as Le Mans, and as of January 2021, the Dakar, which is 2 weeks of arduous cross-country rallying now held in Saudi Arabia. Through a joint venture between Prodrive and the Kingdom of Bahrain, we designed and developed an all-new T1 4x4 prototype race car. The Prodrive Hunter, run by our own Bahrain Raid Extreme team, was driven by Dakar legend Nani Roma to 5th place, the best result for any new team in the modern era. Prior to this year's Dakar, there were some important changes to the regulations, meaning Prodrive had to engineer a big update to the car in a limited time. The new T1 Plus car is wider, has bigger wheels, longer suspension travel, and is more capable in rough, rocky sections with improved grip in soft sand. The new cars achieved 2nd and 4th overall, with 9 times world rally champion Sebastian Loeb at the wheel of the lead car. The Dakar programme is a great example of Prodrive projects, which typically involve the design and manufacture of many high-performance, bespoke components. The car is a ground-up design, not derived from an existing model, and consists of a complex assembly of over 10,000 parts. We are always careful to select the right materials and production methods for every component, ensuring we firstly have reliability, but also the highest performance possible within our budget. With each technical advancement of additive manufacturing processes and machines, we are seeing more and more cases where such parts are replacing those produced by traditional methods. The reason we like our existing FFF machines from BCN 3D is that we are able to print high-quality parts in a wide range of high-performance engineering materials, such as carbon-reinforced nylon and impact-resistant plastics. In addition, the low material wastage keeps production costs down. But as with any FFF-based machine, some compromises have to be made. The strength of the material in the finished parts is not fully homogeneous, particularly under tension loads in the Z direction. And the surface finish is not up to the standard we're looking for. Also, as with most additive manufacturing parts made from structural materials, the build time increases significantly as the quantity of parts in the build is increased. VLM technology seems to combine all the best features of the different additive manufacturing technologies and even offer some unique advantages. Right away, we knew that we wanted to get involved in the VLM technology adoption program from BCN 3D and try to make some of our existing FFF parts with VLM. For Prodrive, materials are the key to making durable end-use parts. VLM allows us to continue to use the engineering materials that we know and love, but instead in significantly finer resolution in all 3 directions. And the material is much more homogeneous, making the finished parts behave much more like a traditional injection molded part. Not only that, but via the VLM process, a bed full of parts can be printed in the same time as it takes to make a single part, which really unlocks the potential for producing end-use parts in significant quantities. There have been times when we simply couldn't make parts quick enough on our FFF machines, with the only solution being more machines. With VLM, we're unlikely to face that problem again. Also, harvesting the unused polymers and reusing them is a very nice feature in a modern world where sustainability is at the forefront of people's minds. The final jewel in the crown of VLM is the potential to print parts from 2 different materials in the same build. We have already thought of several applications for this, where we could print a component with a flexible element fused seamlessly to stiff mountings. So far, one of the VLM parts we have produced with the engineers at BCN 3D is a trim part next to the rear light of the Hunter. This trim pot is in a harsh environment behind the rear wheel and could be subjected to quite a lot of abuse, particularly if a crew suffers a puncture. It is also visible, so the finish is important. It is a complicated part geometry-wise, and when we used the FFF machines, it required a specific build orientation to get the finish we needed. However, this orientation was not the optimum for strength, so the parts were a little delicate. Ideally, we'd have an even finer finish since it's so visible, and better impact resistance and strength to live in its environment. The first samples made using VLM technology are really impressive. The finish is a huge step forwards compared to FFF, and they feel really robust in the hand. We have a vehicle test coming up in the Middle East soon, and we're looking forward to seeing how the parts perform in the harshest environments. So far, it looks very promising, and I predict we'll be using VLM for all our polymer additive manufacturing before long.
Many thanks to Callum and the Prodrive team for their valuable participation, both today and throughout our VLM development stages. I am Diego, the product manager here at BCN3D, and my role today is to show you how productive VLM can really be. Let's review how using two factors with high influences on productivity. The first factor is layer time. We can group different AM technologies depending on the strategies used to build a layer that directly affect how much time it takes to print one. Technology number one, rastering. Extrusion technologies like FFF or those using a laser as an energy source, like SLA or SLS, must raster the entire layer, so the more parts in the build plate, the longer it takes to print the layer. Or you could use what is called printhead jetting. This is where, in some powder-based technologies like binder jetting or multi-jet fusion, the printhead must pass once or multiple times above the print area in order to print a layer. In this case, the layer time is uniform, independent of the total amount of parts to print. Another technique is image flashing. Some resin-based technologies, instead of using a laser as a light source, use a projector or an LCD screen. This is the case of VLM. As the light source flashes, the whole build plate is cured. Again, the layer time is independent of the amount of parts in the build plate. In VLM, all the steps to print a layer take less than 10 seconds. The second factor with a profound impact in productivity is scalability. Engineering, usability, and key component sourcing all need to be taken into consideration, as well as printing times and the equipment costs as the solution grows bigger. FFF, SLA, or SLS are not the best candidates to scale up, since the more parts you have to print, the longer it takes. Printhead jetting solutions are technically very complex and require tight environment control, so scaling up turns out to be very expensive. However, LCDs are inescapable. We have dozens of them around us, and every year they are even bigger and with higher resolutions. Do you remember a few years ago when 32-inch screens appeared to be incredibly big, or when the first full HD screens arrived? Well, nowadays we are more than used to dealing with 50-inch 4K screens, and maybe this growth will continue. It is clear that LCDs are the best options to scale up, not only in size but also in resolution. And since VLM is not requiring complex temperature control or fancy components, scaling it up does not equal a critical cost increase. It's clear that the combination of quick layer time with easy and affordable scalability grants VLM the serious potential to disrupt the AM productivity landscape. And what better way to illustrate these benefits than by passing the mic to our speakers from Tier 1 automotive glass manufacturer Saint Gobain. World-class manufacturing manager Alberto Rodriguez and temporary and soldering manager Miguel Las Cuevas are here to tell us about their first-hand experience in using VLM as a pilot participant in our VLM technology adoption program.
Hi everyone, I'm Alberto, World-Class Manufacturing Manager at Saint Gobain.
And I'm Miguel, Tempering and Soldering Manager.
and we are here today to explain what drove us to participate in the VLM Technology Adoption Program and all the advantages we have experienced so far. We work at a business inside Saint Gobain called Securit, where we create innovative glazing systems for the automotive industry. The top leader of this sector for over 90 years. We have 31 plants distributed across 20 countries. In our facilities in Larbos, we annually produce around 90 million backlights and sidelights for car manufacturers such as Stellantis Group, Daimler Mercedes, Volkswagen Group, Renault Dacia, and Ford. We've had 3D printing integrated into our shop floor since 2019. We create anything from tools, jigs, and fixtures to spare parts and prototypes. Each one of them has notably reduced our cost per part and the lead time.
Before the implementation of 3D printing in our factory, we were outsourcing all our parts to be mechanized by a external supplier. This was an expensive process and didn't work well with our phase-paced schedule and the urgent lead times that we have for each piece. With 3D printing, we can experiment with design, test them right away, and obtain the best quality, all while still at a low cost. But we knew there was room for improvement in our production of large batches. We found this to be particularly true in a positioning fixture in our production line. In this process, we have robots that pick up a cable, which is then welded to backlight glazing. This cable is used for the fogging system. The problem we faced was that the cables were sometimes badly orientated and not picked up properly. The glazing would then have to be reworked manually by one of our operators. As you can imagine, we want to speed up the process and make it as efficient as possible. We found that the issue was the tray, and so we decided to create positioning fixture with the teeth to separate the cables and hold them in place. Since we were manufacturing a huge number of these components, it meant that we required 7,000 units of this fixture, and we needed them fast. We began to weigh our options, producing this large batch internally with our resin and FFF printers at the time would work cost-wise, but the lead times just weren't feasible. We then looked into external 3D printing service suppliers, but this came with an unsustainable cost per part. From discussion with VCM 3D, we came across VLM technology. With a promise to quickly and affordably produce these 7,000 units, we put our trust in VLM, and the result has been an estimated annual saving of 70,000 euros.
With the massive range of robots, processes, and applications Saint Gobain has, we are also aware of the huge opportunity to expand this breakthrough to other areas. We are planning to apply VLM in all cases where a position fixture such as this could be implemented in different shapes, sizes, and quantities. Of course, this will have the knock-on effect of even more savings in time and money. VLM technology has empowered us to see significant improvement in the future. Our main goal is to reduce our dependence on external mechanization suppliers and do it internally instead, with technologies such as VLM. Doing so is what will give us the power of manufacturing autonomy. We'll simply produce what we need whenever we need it. A big target for us at Saint Gobain is achieving operational excellence. We want our operators to be proposing, designing, and implementing solutions with their own tools. VLM allows us to get closer to this goal by ticking all the boxes we were looking for. We know that this first step has opened the door for many more possibilities to come. It's a technology that really any manufacturing line can benefit from. Over to you, Diego.
A big thank you to Alberto and Miguel for their essential input into this project and their insights today. Now, let's dive straight into the data showing the productivity of this case. Saint Gobain needs to produce a 7,000-unit batch. Therefore, we have 3 factors to consider in order to choose the right manufacturing technology. The cost per part, including fixed, variable, and labor costs, the amortization, which could be considered as the entry barrier or the required financial initial investment, and finally, the lead time. There are different commercially available candidates on the table: the well-known FFF, a highly productive powder-based technology, and the state-of-the-art resin-based technology that claims improved speed and part performance. So, how do they compare in terms of cost per part? And what is the lead time in each case? FFF offers a reduced cost per part because of its simple operation and cheap material cost. However, due to the low productivity, fixed costs are quite high and lead times are simply unacceptable. It would be necessary to install a farm with multiple printers to reduce this to a reasonable time period. Powder-based technology offers a competitive price and a very short lead time of just 6 days. Materials and consumables are more expensive, while labor costs are kept low by the high automation of the workflow. The downside here is the huge initial investment required, meaning only financially strong businesses with a very clear 3D printing pipeline could afford it. In third place, commercial resin alternatives offer a much higher cost and 3 times longer lead time than powder-based technology, with a similar investment, with relevant labor costs due to a small build volume. So, how does VLM compare to these figures? The overall cost per part is the lowest one, with a very competitive lead time, just 7 days to get the full 7,000 unit batch. How is that? Well, since the equipment has a low entry barrier, a big printing volume and high throughput, the fixed cost of the solution is absolutely game-changing compared to other alternatives. Here you can see at a glance what benefits VLM brought to Saint Gobain. This is why we believe this technology can unlock manufacturing autonomy for all kinds of companies, productively and affordably. To sum up, in this real use case by Saint Gobain, compared to powder-based technology, VLM saves 85% of the initial investment, produces parts 17% cheaper, and only requires 1 extra day to produce the 7,000 unit batch. Compared to other resin-based technology, VLM requires 83% less initial investment, produces parts 37% cheaper, and cuts lead time in half. I hope that I have covered all you need to know about VLM's productivity. We will now put the spotlight back on our CTO, Eric, to hear about his findings regarding accessibility.
I'm back to talk about the last, but certainly not least, third pillar in achieving manufacturing autonomy, which is usually the most forgotten aspect in the other solutions out there. But first, what are we talking about when we mention accessibility? Most people may think about financials, and they are definitely right. Did you know that more than 99.8% of the companies in Europe and the US are micro, small, or medium-sized businesses? In most of these scenarios, these kinds of companies are not capable of investing in an additive manufacturing technology with a price tag starting at around 500,000 euros. On top of that, also take into account the required space, footprint, and infrastructure that some alternatives need, which have some hefty financial implications. As a result, for SMEs, producing with AM technologies is an unreachable dream nowadays. However, unlocking manufacturing autonomy using 3D printing shouldn't be just for Fortune 500 companies, but for every single business that develops or manufactures concepts or products in any industry. VLM is here to open the door to the 99.8% of companies willing to produce locally in a more sustainable way. VLM-based solutions will be under 50,000 euros, a reduction of 10 times over, with a compact footprint, no dedicated space, nor critical infrastructure. Manufacturing autonomy can be unlocked by all kinds of companies thanks to VLM's financial accessibility. Another key aspect related to accessibility is easy operation and zero waste. As you have seen in the video, VLM technology has no VAT, which makes its operation smooth. For example, legacy large format SLA printers have a huge tank to be filled with hundreds of liters, an economic pitfall, and a hassle to clean or switch materials. On the other hand, large format LCD printers usually require a 2-person operation to install the build plate or clean the vat. Or, if you consider powder-based technologies, we need to bear in mind that powder is explosive and potentially harmful for your lungs, so dedicated space with infrastructures like ventilation and air extraction are of the utmost importance. In contrast, by using high viscosity resins, VLM presents multiple operation advantages. For example, the absence of a vat makes the cleaning process straightforward. In addition, the resin is stored in an independent cartridge, and changing materials is a matter of a few seconds. Regarding zero waste, as we mentioned before, other alternatives heat up the resin or use by component formulations. In both cases, the pod life, which is the time when the resin is printable with stable properties, can be dramatically shorter, even shorter than the time required to finish a print. As a result, an important amount of resin must be disposed, so variable costs of operation rise and chemical waste management gets more complex. Since VLM operates at room temperature and doesn't require mixing, the pod life is no longer a limitation. Furthermore, all the resin applied in the film is either photopolymerized or recovered, filtered, and recirculated back to the resin reservoir. In other words, all the resin eventually becomes a printed part. And so that concludes my segment on the wonders of VLM's accessibility, meaning it's time to bring back our CEO, Xavi, for his final thoughts.
I'm sure you're blown away by all the data that we just explained. We really didn't want to miss the opportunity to demonstrate the full potential of VLM technology. VLM is a really flexible technology that we strongly believe will fit into many different applications. But even with all of our experience, we know that it's you, those who use 3D printing every day in real-life applications, who have the extra practical knowledge that's needed to bring VLM to the next level. We want to understand you, and we want you to understand VLM, so that the next steps we take result in a range of applications as wide as possible. If you are interested in manufacturing, and we assume you are because you are here in this presentation, it's definitely time to join our VLM technology adoption program. Whatever industry you are in, we want to hear from you. We've set up a printing center operated by additive manufacturing specialists to host our upcoming VLM-based solutions. Like the cases you've seen today with Saint Gobain and Prodrive, by joining the program, you will be one of the first to discover the new VLM technology and see its full potential for yourself with real 3D printed parts. At BCN 3D, we are grateful to have the opportunity to push technology forward, in this case, through our expertise in 3D printing. We are sure you all have had experiences where you failed to obtain what you needed, or simply just couldn't afford it. VLM is the chance to turn this around and build something completely new together. Let's do it.